Generative AI. It's the phrase you hear everywhere now, isn't it?
Absolutely everywhere.
It's shaping our world so fast, and often, like, we don't even realize it's happening.
Right. Under the hood.
Yeah.
Yeah.
From, creating art that actually wins competitions
That was something else.
to the tools we're starting to use every single day at work. It's just sparking these incredible changes.
Mm-hmm.
So today on the deep dive, we're kind of on a mission, really.
Yeah.
Let's cut through all the buzz and really try to understand what generative AI actually is, how it's evolving so quickly, and importantly, its real impact on your life.
It's a fantastic goal. It's
Yeah.
such a dynamic field, and
Mhm.
honestly, all the curiosity around it.
Right.
Totally understandable.
Right.
So yeah, this deep dive, we've looked at the sources, and the aim is to pull out the key insights for you, give you a clear, kind of concise understanding of this, well, game-changing tech.
A shortcut, maybe?
Think of it like that, yeah. Your fast track to really getting generative AI.
Okay, love it. So, to really get it, we probably need to lay some groundwork first.
Make a sense.
Before we jump straight into generative AI, maybe let's just clarify the bigger picture. What exactly is artificial intelligence? And how do machine learning and deep learning fit in?
Okay, good starting point. So artificial intelligence, AI, that's the big umbrella term, right?
Right.
It's basically about machines trying to emulate human intelligence, human behaviors.
The broadest concept.
Exactly.
Right.
Then sort of nested inside that, you've got machine learning, ML.
Okay.
And that's where systems learn and improve automatically from data. They're not explicitly programmed for every single step.
Got it. They learn as they go.
Precisely. And
Yeah.
then even deeper, right at the core, you find deep learning.
The third layer.
Yeah, it's a subset of machine learning. It uses these, well, complex algorithms, deep neural networks, and usually vast amounts of data.
You described it like layers of an onion before we started.
Yeah, that's a decent analogy. Each one's a more specialized form of the last.
That helps. And it's not just theory, is it? It's actually weaving into our lives.
Oh, absolutely.
I mean, I was reading about AI being used in museums now to give you info on artists like Liu Kang,
Oh, interesting.
or even creating totally new perfumes. It just feels like it's popping up everywhere.
It is pervasive.
What about you? What's an AI interaction that maybe surprised you recently, or one people might overlook?
That's a good question. For me, maybe how good AI has become at summarizing really complex research papers.
Oh, yeah.
Yeah, it genuinely saves me so much time, helps me stay informed. It's quite impressive.
I could see that being useful.
And like you said, we all interact with AI daily.
Yeah.
Things like Siri, Alexa, ChatGPT. Those are common examples.
Right. The ones we know.
And mostly what we're dealing with today is what we call narrow AI or ANI.
K and I.
Okay.
Yeah.
These are systems designed for specific, defined tasks. They do one thing well.
Like translation or playing chess.
Exactly. But then there are these bigger sort of aspirational goals. There's artificial general intelligence, AGI.
AGI, that sounds bigger.
It is. That's the idea of machines being as smart as humans across the board, able to learn continuously.
Like truly thinking.
That's the debate, but essentially matching human cognitive abilities. And then even beyond that, there's artificial superintelligence, ASI.
Okay, now you're scaring me slightly.
Huh? Well, it's theoretical. ASI would be intelligence surpassing human capabilities entirely.
Wow. Okay, so ANI, AGI, ASI. That's a helpful spectrum.
It is. And understanding that helps frame where we are now and where things might be heading. We also sometimes talk about types based on function, like reactive machines, limited memory, theory of mind, self-awareness. But the narrow general superclassification is maybe easier to grasp initially.
Got it. And what's really striking is how long this journey actually is. I mean, we think of AI as new, but the ideas go way back.
Way back.
Alan Turing, the Turing test, that was 1945.
Incredible, isn't it?
And John McCarthy actually coined the term AI in 1956.
Yep. Gave it a name.
And even before that, the basic concept of neural networks was worked out in 1943.
By McCulloch and Pitts, yeah. Foundational work.
So this wasn't some overnight sensation. It's been building, simmering for decades.
Absolutely right. And it wasn't a smooth ride either. Definitely not linear.
Oh.
We had what people call the AI winters.
AI winters, like lean times.
Exactly. Periods in the 70s and 80s, and then again in the 90s and early 2000s where funding just dried up, interest waned, big promises maybe didn't deliver quickly enough.
Ah, okay. So hype cycles, essentially.
Kind of, yeah. But then things started picking up again significantly. Around the year 2000, deep learning started making real progress. crossing the desert, as some put it, especially with language modeling.
Right.
Then a huge leap was the transformer model in 2017.
The transformer, that name comes up a lot.
It's crucial. We'll probably talk more about it. Then more deep learning progress in 2019. And all this really culminated in what we're seeing now, this large-scale era.
Which exploded with ChatGPT.
Exactly. When ChatGPT became widely available in late 2022, early 2023, that's when it really hit the mainstream consciousness. But it stood on the shoulders of all that previous work.
Powerful reminder. Today's breakthroughs have deep roots.
Definitely.
Okay, so we've traced this long history, the ups and downs, the foundational tech like deep learning. But now, generative AI. What makes this specific wave so different? Why is it causing such a, well, frenzy right now?
Yeah, the key difference, the defining characteristic of generative AI is its ability to create.
Create, not just analyze.
Exactly. It generates entirely new content. That could be text, images, code, audio, video, you name it. It's not just classifying data or making predictions based on existing patterns. It's making new stuff.
Okay, that is a fundamental shift.
It is. And many of these models, like GPT, are what we call autoregressive.
Autoregressive, what does that mean in simple terms?
It basically means they generate content step by step, where each new piece depends on the ones that came before it.
Like building blocks.
Sort of. Imagine you're typing a sentence. Each word you choose influences the likely next word, right?
Sure.
Autoregressive models do something similar. They estimate the probability of the next word or the next pixel in an image based on the sequence generated so far.
So it predicts what comes next, sequentially.
Precisely. That's how they build up coherent text or images, ensuring a kind of natural flow. It's like they're thinking ahead step by step.
Yeah.
Models like PixelRNN or PixelCNN for images work this way too.
That makes sense. Creating, not just analyzing. And you mentioned the transformer model earlier.
Yes.
Our sources also highlight attention-based models. Are they related? What's the magic behind this attention concept?
They are very closely related. Attention mechanisms are a key part of the transformer architecture.
Okay.
The magic of attention, well, it's the model's ability to weigh the importance of different parts of the input data when it's generating the output.
So it focuses on what matters most.
Exactly. Think of the sentence. The cat sat on the mat. When the model is figuring out where the cat is, the attention mechanism helps it realize that mat is way more important than, say, the.
It gives more weight to relevant words.
Precisely. It dynamically focuses on the crucial bits. Now, transformer models, like GPT, they typically have two main parts. An encoder, which reads and understands the input.
Like reading the prompt.
Yeah. And a decoder, which generates the output, the response, or the image.
Got it. Encoder, decoder.
And a key difference from older models, like recurrent neural networks or LSTMs, is that transformers don't process data sequentially, word by word.
Oh. How do they do it then?
They can look at the entire input sequence, the whole sentence or document all at once, thanks to that attention mechanism.
So they get the full context immediately.
Right. This allows for parallel processing, making them much faster to train, and it leads to a much better grasp of context and nuance.
Faster training, better understanding.
And crucially, they can be trained effectively on absolutely massive data sets. That scale is a huge part of why they're so powerful.
No wonder they've taken off. Which brings us back to that adoption rate. Our sources say industry adoption of AI technology is faster than ever.
It really is staggering.
What do those numbers actually look like? How fast are we talking?
We're talking unprecedented speed. Generative AI has a much steeper initial adoption curve than, say, smartphones or tablets did.
Really? Faster than smartphones?
Significantly in the initial phase. Look at the U.S. user numbers. Year one, which basically starts with ChatGPT's public release in November 2022, hit 16.3 million users.
Okay, 16 million pretty quickly.
Then projections for year two jumped to 77.8 million users.
Wow.
Year three, 92.8 million. And by year four, the forecast is 116.9 million U.S. users.
That's incredible growth. How does that compare again?
Well, smartphones from their 2007 launch took 4 years to reach 62.2 million users.
Okay.
Tablets, launched in 2010, got to 40.4 million users in the same 4-year time frame.
So GenAI is blowing past those early numbers.
By a huge margin. It's a remarkable pace, unlike anything we've really seen with previous major tech shifts.
What do you think is driving that? Why so much faster this time?
That's a great question. I think accessibility is a huge part of it.
How so?
You don't need to be a coder or a data scientist to start using tools like ChatGPT or Midjourney. The interface is often just natural language.
Right. You just talk to it or type a description?
Exactly. That lowers the barrier to entry enormously compared to, say, early internet adoption, or even smartphones initially. Plus, the results are often immediately visible and, well, impressive.
Instant gratification, almost.
Kinda, yeah. That definitely fuels adoption. Which naturally leads us to the big question everyone asks.
Ah, yes. The elephant in the room. Will AI take away our jobs?
It's the number one concern, understandably.
So what do the sources say? Are the robots coming for us?
Haha. Well, the nuanced answer is captured really well by one statement we found. It's not AI that is going to take your job, but someone who knows how to use AI might.
Okay, that's a powerful distinction. It's about the tool and who wields it.
Precisely. It's about augmentation, not just automation. If you look at the skills most likely to be substituted or heavily impacted by generative AI,
What are they?
things involving processing large amounts of information, certain types of writing and analysis, basic coding, some aspects of marketing and media creation, skills related to, say, artificial intelligence and big data, have a high capacity for substitution, as do basic reading, writing, math tasks.
Okay, so routine cognitive tasks, maybe?
Largely, yes. But then you look at the skills with very low capacity for substitution.
And those are?
Empathy and active listening, critical thinking, complex problem solving involving real-world ambiguity, sensory processing abilities, manual dexterity, things that are inherently human.
So the skills that require deep human connection, judgment, or physical interaction are safer.
Much safer, yes.
Yeah.
It's not about wholesale replacement, but a redefinition of roles and tasks. There's this concept of the shifting human-machine frontier.
Okay, tell me about that.
Projections show that the share of work tasks performed solely by humans is expected to decrease maybe from around 47% now down to 33% by 2030.
That sounds like a drop.
It is. But look at the other parts. Tasks performed solely by technology are projected to rise from about 22% now to 34% by 2030.
Okay, machines doing more.
But the crucial part is the collaboration. Tasks performed by a combination of humans and technology are projected to stay significant, maybe even increase slightly, from 30% now to 33% by 2030.
Ah, so the future is human AI teams.
That's the picture emerging. Success and job security will likely come from learning how to work with these tools effectively, leveraging them to do what humans do best, even better.
Less competition, more collaboration.
That seems to be the most productive way to look at it.
Okay, that makes sense. So it's clear generative AI isn't just some niche thing. It's hitting pretty much every part of the economy.
Absolutely.
Where are we seeing the biggest impacts right now? Which business functions are being transformed the most?
Well, the data shows it's really widespread. But the highest impact reported is often in IT departments. Around 65% see a significant impact. Think automation, code generation, troubleshooting.
Okay, IT makes sense. Where else?
Customer service and contact centers are also high, about 59%. Chatbots, automated responses, summarizing calls, that kind of thing.
Right, freeing up agents for complex issues.
Exactly. And product or service development is up there too, around 54%, using AI for brainstorming, design iteration, market analysis.
So core operations and innovation.
Yeah, but it touches almost everything: marketing, sales, finance, HR. The list goes on.
And it's not just abstract corporate strategy, right? You mentioned earlier how it's showing up in everyday tools.
Totally. Think about things like Microsoft Copilot.
Ah, yeah. The AI assistant in Office.
Right, integrated directly into Excel for data analysis, into Outlook for drafting emails or summarizing threads, into PowerPoint for creating presentations.
So it's right there, potentially helping with tasks you do, like dozens of times a day.
Exactly. It's becoming embedded in the workflow.
That makes it very tangible. What about specific industries? Can we break down some examples?
Sure, the applications are incredibly diverse. In healthcare, for example, it's huge.
Beyond just admin tasks.
Oh, yeah. We're talking accelerating drug discovery, making medical imaging analysis more accurate, predicting disease outbreaks, assessing medication effectiveness,
Wow.
even generating synthetic medical data for research without privacy concerns, personalizing medicine, analyzing vast amounts of research. The potential is immense.
That's transformative stuff. What about, say, retail?
Retail is another big one. AI powers chatbots for customer service, provides automatic translation for global sites, writes product descriptions.
Saves a lot of time, I bet.
Definitely. But also things like optimizing product recommendations, personalizing marketing, even helping with new product design based on trends, and behind the scenes, improving employee experience, speeding up software development, data analysis, freight tracking.
Okay, front end and back end.
Exactly. Then you have financial services. We saw that stat earlier. Huge adoption.
92% using it for fraud detection?
Yep, fraud detection, answering customer questions, managing virtual assistants, that's all around 92%. But also recommending products, 89%, managing accounts, 86%, even helping manage investments, 84%.
It's becoming core to their operations.
Very much so. And think about travel dynamic pricing for flights and hotels, predicting flight delays.
That would be useful.
Right. Or logistics and supply chain, making deliveries more efficient, managing inventory more accurately, optimizing warehousing, improving safety, reducing costs. Tools like ChatGPT, DALL-E, BERT, Bard are being applied here.
It really is touching everything. Marketing, sales, social media, automation like self-driving cars, credit and insurance using it for claims and risk.
The list just keeps growing. It's becoming foundational technology across the board.
It's genuinely pervasive. And like you said earlier, it's not just about text.
Not at all.
Let's zoom in a bit on the different types of generative media. What else can Gen AI create besides words?
Right. So beyond text, where we've seen things like content summarization, digesting long reports into quick summaries, and language augmentation.
What's language augmentation again?
That's basically generating extra synthetic examples of text to help train other AI models, like creating more examples of positive or negative reviews to improve a sentiment analysis tool.
Ah, okay. Training data creation.
Exactly. And of course, increasingly sophisticated language translation. But then you get into image.
Okay, image generation. This is where things get really interesting and maybe controversial.
Definitely. AI can not only generate images, but it can also help analyze them. For instance, spotting potential fakes using techniques like ELA, error level analysis.
Looking for inconsistencies.
Kind of, yeah.
Well,
Looking for digital artifacts that suggest manipulation. But the creation side uses things like AI diffusion models.
diffusion models. How do they work? Simply.
Imagine starting with random noise, like TV static, and gradually refining it, step by step, guided by a text prompt until it becomes a coherent image.
From noise to picture.
That's the basic idea.
Mm.
And this led to that famous case, Théâtre de Wera Spatially,
Right, the artwork that won the prize at the Colorado State Fair in 2022.
created by Jason Allen using Midjourney, an AI image generator. And yeah, it sparked a huge debate.
Artists weren't happy.
Many felt it was cheating, even plagiarism, devaluing human creativity. But Allen's point was, I won and I didn't break any rules.
And the judges.
They initially didn't know it was AI generated, but later said they stood by their decision, awarding the prize based on the work itself.
Fascinating clash.
It really highlights the questions around authorship, creativity, and the role of tools. And these tools, like Midjourney, which was also used for those viral fake photos of Trump's arrest, or the Pope in a puffer jacket,
Ah, those.
and DALL-E 2 from OpenAI, based on their GPT models. They're incredibly powerful. They can create photorealistic images, original compositions, not just copying things.
It really feels like the only limit is your imagination with the prompts you give it.
Pretty much. You type in a distant galaxy filled with tiny, colorful stars, a blue, Earth-like planet in the foreground, realistic, colorful, 8K, trending on ArtStation.
And it makes it.
And it attempts to generate exactly that. It's also used for editing and manipulation, changing facial features, adding or removing objects, generating new scenes. There are techniques like conditional GANs,
Jans.
generative adversarial networks. Think of it like two AIs competing. One generates fakes, the generator. The other tries to spot them, the discriminator. They push each other to get better and better.
A creative arms race.
In a way, yes. This is used for things like virtual clothing try-ons, generating realistic variations.
Okay, so text, image. What else?
Audio and video. The
Yeah.
principle is similar. Train models on huge data sets of sound or video, let them learn the patterns, and then generate new content.
Creating music. Synthesizing voices.
Yes, or enhancing sound quality, removing noise. And for video, generating short clips, animations, or even creating digital avatars.
Colors, like in games.
Can be. An avatar is just a digitally constructed visual identity. It could be object-based, character-based like emojis, or increasingly realistic, human-like ones, like the Baby X project exploring digital consciousness.
Okay, the possibilities seem almost endless there.
It's expanding very rapidly.
This has been an incredible overview of the capabilities, from the core tech to the creative outputs. Can we look at some specific real-world case studies that really showcase the impact?
Definitely. There are some standout examples. One huge one is Google's DeepMind and AlphaFold 2.
AlphaFold, I've heard of that. Proteins.
Exactly. It's an AI system that predicts the 3D structure of proteins based just on their amino acid sequence.
Why is that important?
Protein structure determines its function. Understanding it is fundamental to biology, medicine. Think drug design, understanding diseases, creating new materials like vaccines or enzymes. AlphaFold 2 is a massive breakthrough.
How accurate is it?
Astonishingly accurate. It's predicted the structures of virtually all known proteins. We're talking around 200 million of them. It's revolutionizing biological research.
Okay, that's genuinely world-changing potential. What else?
Then there's NVIDIA's StyleGAN.
StyleGAN. You mentioned GANs earlier.
Right. StyleGAN is particularly good at generating incredibly convincing but completely fake human faces.
This person does not exist websites.
Exactly like that.
Yeah.
It's clever because it can separate high-level attributes like someone's pose or identity from random variations like freckles, hair texture, or skin details.
So you can control the output more.
To a degree, yes. Applications range from AI-generated art and design to creating synthetic data for medical imaging research, even e-commerce and fashion modeling.
Interesting. Okay, what about manufacturing?
Bridgestone, the tire company, is a great example. They're using AI in their virtual tire development, or VTD.
Virtual tires.
Yeah, they use AI to rapidly assess different tire designs digitally, simulating performance without having to build and test physical prototypes for every single variation.
That must save a lot of time and resources.
Huge amounts.
Yeah.
They project it will save them from making around 12,000 experimental tires every year. That also means a significant reduction in their CO2 footprint from manufacturing and testing.
Efficiency and sustainability benefits.
Nice, definitely. And then in the consumer goods space, look at L'Oreal.
The beauty company. How are they using AI?
They've developed AI tools that act as personal beauty assistants.
Like recommending makeup.
Exactly. It uses vast amounts of data, 11,000 terabytes mentioned in one source, to provide real-time, personalized analysis and product recommendations across thousands of their products. It's like having an expert consultation via an app tailored to you.
While ensuring data privacy, they claim.
Yes, that's a key point they emphasize.
Okay, one more. Maybe automotive?
Sure. BMW. They're integrating AI tools directly into their DesignWorks studio.
For designing the cars?
Yes, using AI to generate design ideas, allowing for much faster iteration than traditional sketching or modeling alone. It speeds up the early stages of the design process.
So AI as a creative partner for the designers.
That seems to be the goal. Using it to explore possibilities quickly, ultimately aiming to improve the driving experience and user interaction through better design.
These examples really drive home that point. Every industry needs AI.
It certainly seems that way. The potential applications are just so broad.
But this also brings us back to some important questions, doesn't it? Potential downsides, fairness, bias, ethics.
Absolutely critical considerations, and our sources do touch on these. We need to be aware of examples of unfair biased outcomes.
Like what?
Well, one example given is in medical diagnoses. If an AI system is trained primarily on data from one demographic group,
It might be less accurate for others.
exactly, its accuracy could vary based on gender or race, potentially leading to wrong diagnoses or delayed treatments for underrepresented groups. That's a serious concern.
Yeah, that's deeply problematic.
Another example is targeted advertising. While AI can make it very efficient,
It can also reinforce stereotypes.
it can, yes. By learning patterns from existing data, it might inadvertently limit exposure, showing certain groups only specific types of jobs or products, for example.
Locking people into boxes based on past data.
That's the risk. And beyond bias, there are broader concerns about things like personal data collection and how it's used, and the general lack of transparency, the black box problem in how some complex AI models arrive at their decisions.
So, powerful tools, but ones we need to deploy thoughtfully and ethically.
Absolutely. Constant vigilance and ethical frameworks are essential as this technology becomes more integrated into our lives.
So after this really comprehensive deep dive, navigating the history, the tech, the applications, the concerns, what's the most important takeaway for someone listening? What should they really focus on?
I think the core message isn't fear, but preparedness. It comes back to that idea about jobs. It's about adaptation.
Right.
The key things to focus on are acquiring new competencies, particularly those that complement AI.
Like critical thinking, creativity, emotional intelligence.
Exactly.
Hmm.
Also, being willing to shift career aspirations as the landscape changes, embracing technological change rather than resisting it, and fundamentally developing AI awareness, understanding what it can and can't do, and how it's impacting your field.
So lifelong learning and adaptability are paramount.
More than ever.
Hmm.
The future seems to belong to those who can effectively collaborate with AI, leveraging its strengths while applying uniquely human skills.
That's a great summary. We've really journeyed through this incredible landscape of generative AI today, from, its surprisingly long history,
The winters and springs.
yeah, to the cutting-edge applications we're seeing pop up everywhere across every industry, and thinking about its impact on work, on creativity.
Hmm.
It's profound.
It really is.
And it's clear this isn't just some abstract tech for big companies anymore. It's something that's going to increasingly shape your day-to-day work, your creative outlets, how you interact with the world.
And hopefully this deep dive has given you the knowledge to understand the what and the why behind it all. To feel empowered, not intimidated, and maybe connecting this all together, it leaves us with a thought, a question for you to ponder as generative AI keeps evolving.
Okay.
Where do you see the most exciting, but maybe also the most challenging frontiers opening up?
Hmm.
Where is that cutting edge of human ingenuity collaborating with these incredibly powerful new machine capabilities?
Mm. A lot to think about there. Where do human creativity and AI power meet next?
Exactly. Something to mull over.